Hello, this is the data analysis pros and cons video where we will be taking a look at the goods and bads of the three graphs we introduced before. We talked about how data is typically organized into a data table when being presented, but to emphasize a certain trend, pattern, or point from the data, you can use a variety of visual graphs like the bar graph, line graph, and circle graphs. Let us start with bar graphs. Bar graphs rely on being able to see the data. Bar graphs are good, especially when you're looking for the difference between certain data. Because you can see the data, the trends are right there. It's clear one group is greater than the other group. But what if they're closer together? In that case, it might be much harder to tell between two groups. Another thing to point out is the scale, or the interval between measurements, and how that might make data look more further or closer apart. Here's a quick thing to try. Using a ruler, draw two lines. On the first line, draw a mark at every 1 centimeter. On the second line, draw a mark at every 1.5 centimeters. And now number each mark, so 1, 2, 3, and it should look something like this. Both graphs are showing bars with a measurement of 1, 2, and 3. However, because their scales are different, the length of the bars are very different. Next, let's take a look at line graphs. Line graphs, just like bar graphs, also rely on seeing the data. Line graphs are especially good when you're looking for how the data moves or changes along, in most cases, time. You can even put multiple line graphs on top of each other, say about 2 or 3 different line graphs, and still be able to see each graph's data movement clearly. But there are still certain things to be careful about when you're looking at line graphs. Just like bar graphs, you also, for line graphs, have to be careful about the scale. If you want to compare multiple line graphs, they must be using the same scale. Let's go back to the 1 centimeter and 1.5 centimeter lines. This time, I'll add the numbers 1, 2, and 3 on the vertical line as well. At each mark, even though both line graphs show the same data points and therefore are still showing the same trend, without actually calculating the trend, someone who sees the graph would find the lines looking very, very different. Now for circle graphs. If you want to know how much a group of data is compared to the total data, circle graphs are your best friend. Circle graphs are excellent tools for shrinking big numbers into percentages that we can understand. For example, saying about 35.4% of 1,600 people might be a better way than to say 567 people out of 1,600 people. But let's look into percentages a bit more. Let's imagine that student A ran an experiment and calculated that 50% of the beakers turned blue and the 50% turned red. Student B runs the exact same experiment and calculated again that 50% turned blue and 50% turned red. Well, you might think because two students ran the exact same experiments and calculated the exact same circle graphs of 50 and 50, there is no difference whatsoever. But what if student A did 10 trials and student B did 100 trials? Even though the percentages are the same, 50%, student A got 5 blue and 5 red, while student B got 50 blue and 50 red. This issue comes up because percentages are relative values. A percentage is something out of total trials, so while it makes it easier to simplify data, when you're comparing two different sets of data under different conditions, it may not work or it might be misleading. In this case, we can ask these questions. Is 5 beakers really the same as 50 beakers? How accurate would it be to compare these two sets of data? And what's more important to look at then, percentages or raw data? Obviously, 5 beakers is not the same as 50 beakers. 50 beakers from 100 experiments is more confident and reliable. You have to be aware of the conditions of an experiment and read the raw data if you can before you make conclusions.